Hello and welcome to the demo of ZettelCLI. ZettelCLI is a command line application for managing a personal Zettelkasten note-taking system. Zettelkasten is a powerful knowledge management tool that runs entirely from your keyboard. It's designed for students who prefer the speed and efficiency of keyboard commands and want to build an interconnected web of knowledge across all their modules. Today, I'll demonstrate how a student can use ZettelCLI to manage their learning. First, let's launch the application and set up our workspace. As you can see, we start in the default main repositories. Let's create repositories for Year 2 Sem 1 and Year 2 Sem 2. All repository names are automatically converted to lowercase. Let me list all repositories. Now I'll switch to Year 2 Sem 1. Now let's create notes for key concepts from two modules, namely EE2211, Introduction to Machine Learning, and MA1508E, Linear Algebra for Engineering. From linear algebra, I'm capturing eigenvalues, matrices, and vector spaces. From machine learning, gradient descent and loss functions, as well as neural networks. Now watch what happens when I create a node without the -b flag. The application opens my Notepad app where I can edit the body freely. The application waits for me to save the content and close it before it creates the node. This is perfect when I need to write a larger body. Now let's look at the list of nodes. We have 6 nodes, and these nodes are all ID'd. Before continuing, let me prove that all this data persists across different sessions, a critical feature for real-world use. This requires storage. So we have 6 nodes. Now let's exit the application and run the application again. So as you can see, we stay in the same repository and we still have the 6 nodes. Let's print the body of the node, the last node that we saved, the neural network node. And you can see the body is still there. The application automatically saves all changes so that your knowledge base is always protected. Now, what if I forget a node's ID but remember part of its title? I can search for it using the find node by title command. Now, our search query here is gradient, and it will list all nodes with the title that match the search query. So now we can look at its ID. Let's use this for tagging. Let's create a new tag called EE2211, and let's assign the gradient descent node to it. Now here's something interesting. Watch what happens when I add the MA1508E tag to a node without creating the tag first. Let's add it to the eigenvalue node. The system automatically creates the tag even though we never explicitly created it. Let's list all tags that we currently have. So now we have two tags. Let's add the semester tag as well. Let's add the semester tag to the previous two nodes that we added tags to. And let's add to one more node as well, loss function and matrix. Let's add the semester tag now. All right, now that we've added all the tags, let me show the tags on one of the nodes. Let's look at the gradient descent node. As you can see, we have the EE2211 tag and the year 2 semester 1 tag. Now let me demonstrate some more powerful tag management features. First, tags can be renamed globally across all nodes with one command, the rename tag command. So let's rename year 2 semester 1 to AY2425S1. As you can see, the tag has now been renamed. We can also delete a tag globally across all nodes. Let's try doing that. Let's delete the EE2211 tag. So now you press Y for confirmation, and the tag has been deleted. So let's check this. As you can see, we only have two tags now. Let's also delete a tag for an individual node using the delete tag function. So first in the delete tag, we will add the -f flag here so that the system will not ask for confirmation. And then we write the node ID. So let's try deleting it for the gradient descent node. And let's delete the AY2425S1 tag. So now the tag has been deleted. Let's check the tags that are assigned to the node. So no tags are tagged to the node because the AY2425S1 tag was removed and the EE2211 tag was deleted globally. The real power of ZettelCLI comes from linking related concepts. Let me show how concepts from linear algebra can connect to machine learning. Let's just list all the nodes first. Now let's link vector space and matrix within the MA1508E module. As you can see, the two nodes are now linked. Let's also do so for one of the EE2211 modules. So now the neural network node and the loss function nodes are linked. And we can do bidirectional links such that both nodes are linked to each other in both directions. So let's link gradient descent to matrix. As you can see, both nodes are linked in both directions. Now watch what happens when I view incoming links to the matrix node. As you can see, the nodes that link to the matrix node are gradient descent and the vector space nodes. You can even list outgoing links. Let's do so for the same node. And the outgoing link from the matrix node is towards the gradient descent node, as we did a bidirectional link earlier. Sometimes we will need to remove connections, and for that we will need the unlinking command. Let's use the unlink command to unlink vector space and matrix. So now the link from the two nodes has been removed. Let me verify that it's gone. So let's list outgoing links from vector space. As you can see, there's no outgoing links as the link has been removed. Now for bidirectional links, I can even unlink both directions at the same time using the unlink both method. So let's do the unlink both command for gradient descent and matrix. So now all links has been removed. Let's double check this by listing incoming and outgoing links. There's no incoming links. And there's no outgoing links as well. Searching is essential as well. Earlier we searched a node by its title, so let's search it by its body using the find node by body command. Here, it lists the two nodes that contain function in its body, neural network and gradient descent. Now let me show some additional workflow features as well. There's the pin command, which allows the user to pin nodes. Let's pin the gradient descent node. As well as the matrix node. Now let's try listing the pin nodes using the P flag. If priorities change, I can also unpin nodes easily. Let's unpin the matrix node. As you can see, the matrix node has now been removed from the list of pin nodes. I can also edit any node to expand its details. Let's try editing. Now we will be editing the gradient descent node, and a notepad has now been opened. Let's add some additional lines. Let's save it and close it. And as you can see, the node has now been successfully saved. Let's take a look at its body. And the body has successfully been changed. We also have archiving node. Let's create a new node to archive it. Now let's use the archive command. This will archive the node and put it in the archive directory. So when I list the nodes normally, you won't see the new node that we made, but we can still access it using the -a flag, which lists the archive nodes. If I need to work with a node again, I can also unarchive it. So let's unarchive the old nodes. The node has now been unarchived, and we should have 7 nodes now. Now let me demonstrate node deletion. When we delete a node, the system automatically cleans up all its links, both outgoing links and incoming links. Now let's try deleting the neural network node. Let's look at its outgoing links first. And let's look at its incoming links. So it has one outgoing link and no incoming link. Now let's try deleting it. So we press Y to confirm. And now the node has been deleted. So now let's look at the incoming link for the loss function to see whether the link is gone. So the loss function. As you can see, it has no incoming links and the link has been removed. Finally, if the user forgets any of the commands, they can simply use the help command to list out all available commands. Thank you for watching this demo of ZettelCLI.